Okay, so in working with special right triangles, we come across a lot of radicals. We come across a lot of square roots. So I just want to go over properties of radicals and then look at some other examples um, involving these radicals in regard to our topic of special right triangles. But let's look at radicals. So the property of radicals is that whenever you have two numbers, let's just call them a and b, under the square root sign, that we can split them up under their respective square roots. So a times b, the square root of the square root of a times b is equal to the square root of a times the square root of b. So down here, this would look like, for example, the square root of 3 times 7 would be equal to the square root of 3 times the square root of 7. Or this would be the square root of 21. 3 times 7 is 21. We could split that number 21 into two square roots of numbers. Or even you could even take it one step further and just look at, how about 42? This would be the square root of 3 times the square root of 7 times the square root of 2. So we can break a square root into the product of its factors. So let's look at, for example, I have this first example here. To the right here, I've just listed some perfect squares. So square root of 4 is 2, and so on. And our strategy for solving these problems is we're going to take the number under the radicand, so the number under the square root sign, and we're going to divide it by the perfect squares. So 63 divided by 4. 15.5. Let's do 63 divided by, not 6, 9. Oh, 7. So notice. So what I wanted to look for, so this is 63 divided by 9 was 7. So that means that 63 is equal to 9 times 7. Then we will know that the square root of 63 is equal to the square root of 9 times the square root of 7. And you might be thinking, Mr. Hister, no big deal. Well, it is a big deal because the square root of 9 is 3. So the square root of 63 is equal to 3 times the square root of 7. And this is how we simplify the square root, the number under the radical. So we divide by perfect squares, so 4, 9, 16, 25, 36, and see which one results in a nice even split of the number. So here we've divided by 9 and found that 63 was equal to 9 times 7. So we could take the square root of 9 and turn it into to the 3. And we were left over by this number here. I don't know why that did that. Let's look at the next example. I'm just going to leave these square roots over here to the left now. And I'm going to think about, okay, let's try and divide this number by some square roots. So this one by 4. 175 divided by 4. Let's see, 175 divided by 4. Nope. Let's see, 175 divided by 9. Nope. Let's do 175 divided by 16. Again, I'm just going through my perfect squares here. Nope, not a nice even number. 175 divided by 25. Jackpot. Notice I divided by an integer and I got an integer in return. And I divided by a perfect square, 175. So this one did not work. 175 divided by 25. And this turned out to be 7. So that means that 175 was equal to 25 times 7. And then that means that the square root of 175 would be equal to the square root of 25 times 7. And that means that this would be the square root of 25 times the square root of 7. And so this would be 5 square roots.